today's we are going through the class 7th. I mean our 7th class. So today we're covering programming with Hdfs and Spark. So class is mostly, I mean, it's a practical class. So I mean we'll be dealing with accessing Hdfs and running Spark not only from the interactive mode. I mean if we need to run it in a batch mode, and there are many ways we already learned as part of Spark configuration class. So we'll be getting introduced for all those steps and see how what's the suitable method that we need to follow. So just a quick recap. I mean, last class mainly we had an introduction on Python and shell scripting, and we also went through some important stuff that will be required for our class, and already, I mean, some of assignments has been assigned based on the class. Hope you are looking into that. So today we'll see, I mean, we know how to interact with Hdfs using provided libraries, and we know, I mean, how to set up Hdfs. Now, if we need to programmatically access Hdfs file systems and do some operations like reading a file, putting a file, or removing a file. So all these type of operation, if we need to do from a programmatic point of view, how to do that, and also how to deal with Hdfs file in Spark. So I mean, we already have seen this procedure in earlier class also. So we'll be going through in more structured way or detailed way. I mean, to understand and run our Spark job not only in interactive mode but also in batch mode. So and like other last class in Spark, so we'll also do some kind of basic transformation and action in Spark, and see how our interactive transformation actions can be converted to a Python script, which can be submitted to Spark cluster in batch mode in different ways. And then we'll know some theoretical concepts how Spark submit works, because generally we will not be using the interactive shell. Definitely we'll be using batch mode, where we have programmed how to process data and then leave it to in a scheduled job or in an on-demand basis, so that it can run according to the demand. So I mean, if we need to access Hdfs using Python, there are many other ways. So we'll be using two ways. One is standard method. So there is one Hdfs library package. So you need to install that. It won't come with your basic Python installation. So we'll see, I mean, how to install that. Then you need to define one Hdfs cli.cfz, one configuration file according to the package instruction. We need to create that file into our user home directory and put some basic configurations of our Hdfs. I mean, what is the port and IP that we generally use accessing Hdfs. And then we need to import the config or insecure client. So either of the way we should be able to access the Hdfs, and we can do certain operations. So today we will see practically, I mean, if we need to access the Hdfs by sitting on Hdfs OS, or by sitting on our Windows OS. I mean, what's the difference? I mean, how to access that? Another method is very simple. I mean, we use Hadoop and Hdfs, DFS command line utilities. So we also should be able to run those utilities by this package. So we are supposed to use Python 3.4 because compatible with Spark 2. But I was having some in Python because it's went always to Python 3.6. I don't have time to look into that. So what I did, though Python 3.6 is not compatible with Spark 2, I tried to find one workaround and fix Python 3.6 so that it can run even on Spark 2. So I will share, if you also have similar problem, I will share how to do that so that at least you can use or learn the ways to fix these kind of issues. So we'll be going, with some exercise. These are some, concepts how to do that. So the next topic is loading Hdfs file in Spark. I think these are already known to you. We have created RTT from our Hdfs file already. So the new things is, how to create multiple or how to load multiple files at a time in one single RTT. So you just need to put comma and put the different file names, or you can even put regular expression as well. But we need to make sure that the purpose of loading multiple files on the single RTT, or what we are basically going to drive. So we should not, load different kind of data into an RTT, which does not make sense, right? So that we need to make sure. But this is a simple way to load multiple files in a single RTT. And in a similar way, if we come to the data frame concept also, we already loaded one CSV. We already loaded COVID-19 trips. If you remember, using Spark read.format CSV. And we also can load multiple CSV files from either in file system or from Hdfs. So here, the second paragraph, the second portion is loading from a file system, or the first and third one you can see, we are loading from Hdfs. So either we can load from Hdfs or our local file system, or we can load a single file or multiple file, or using a regular expression. So that is supported. So this is way, this is the way, first, anyway, we need to create our RTT and our data frame, and then we do some kind of transformations. And then we ask our Spark to do some actions. Either it can be show us the output, write the output into the Hdfs or in the local file system, or write the output to the MongoDB or SQL, MS SQL, whatever the instruction or process and we are actually asking the actions. So some, basic transformations. So earlier class, we also have seen some transformations. So based on data frame, some more transformation we can see today. So we can see the schema of the data frame. We know that data frame, it has schema, column and data type is attached to that. So whenever you will load one data set, and you can see Apache Spark data frame by default, how it sends you data's data type. So if it is not related to data type that you want to see, maybe you need to change the data type that you would like to, actually see into the data frame, that you need to do it manually in the data frame. So, how to see the data types of each column that you can see. If you loaded some data in data frame df, then you can put df.print schema. The triple array is noting that you are initiated with the PySpark session. But if you are doing some batch programming, these three arrow chino, the notations are not necessary. Column renaming, you have already loaded data frame, so you want to change some columns names. So you can do that. So if df_cm is one data frame, so you should be able to change it. Let's say BTS ID is one column, and we want to change it to BTS ID_cm. And then also there is one more column, segment ID, that we want to change it to segment ID CM. So that can be done by this way. For this, you want to, you need to just import COL packages from PySpark.sql.functions. So this is, how we should be able to rename some columns that is already loaded. You can also drop a column. If you don't want to see BTS ID, you can drop and then see the data frame. And you can also add a totally new column for all the rows in your data frame. And you can also put a certain predefined value, right? So we did some exercise for trips and users, and we did some joining operation between user and trip class, right? So in the driver, passengers, and users. So after the joining, if you want to add one more column, that this is trip, request, and passenger, these are related to one specific, ride sharing company name, brand name, Uber. If you want to create one column, like brand name, and if you want to put a specific value for all the rows in that particular column, you can use lead utility and put this value. It will create one new column with this, and it will keep this static value to all the rows in that particular column. So these are some, common. There are many operations we can do in data frame, and that details has been shared with you. You can go through from the Apache Spark websites, and that is shared part of, as I remember, Spark configuration and installation reference. If you see, you can go through the detailed operation. But these operations, we used to do in day-to-day basis, and it's very required whenever you are doing some analysis. And that's why these are picked up some operation from lot of defined supported operations on top of data frame, so that you can habituate it. There will be one more assignment based on Spark and Hdfs, so that you can use those techniques and you are familiar with that. So in some scenarios, you may have, you do join and you see you have duplicate rows in your data frame. So you want to remove some duplicate rows in your data frame. So this is the way, you just put distinct. So this distinct will, compare all the columns values in each row. If it's similar, then only it will delete, okay? This is the way, we can make our data frame distinct. And we already acknowledged that how to do the partitioning of RDD in last class. If you remember on Spark, that we loaded some numbers in RDD, and we asked the RDD APIs to create around 7 partitions, because sc.parallelize, there are a lot of numbers in the array, and then comma 7. 7 means we want the RDD should be partitioned in 7 numbers, right? So there will be 7 partition for this RDD, and that will be distributed across the executors. So whenever we run any operations, transformation or action on top of this RDD, we saw that there are 7 stacks has been assigned in multiple stages. So the similar action you can also do in terms of data frame. So you can do repartition, and you can mention the repartition number. It's really helpful. Whenever you are facing out of memory error, you either need to tune your memory of executor or driver, or you need to think about shall we go for repartition. And one more point, let's say you have 10 or 15 different type of CSV file, but with same schema. So you would like to do some kind of union operation, so that in one CSV, let's say you are having 10 or 100 rows. In another CSV, you are having more 100 rows. So you want to make one single data frame having 200 rows. So you can do union all. After loading both the CSVs in both data frame, you can do union all operations if both the data frame schemas are same. So it's work like the union all operation we know from the SQL, right? So it's a similar process. So when we write some program for Spark, so we can use PySpark. When we start with PySpark, it is giving us 2 entry points to the Spark. One is a Spark context that we can utilize, and we have seen to be utilized as SC. And we can also use Spark session directly. So Spark session is a modified and advanced feature that has been introduced. If I'm not wrong, it's introduced in Spark 1.6 or 5, and since from Spark 2 it has been used rapidly. But you can also use Spark context. So we'll see both of the entry point, how we need to initialize and how to utilize. But I would request you to always use Spark session, because it has Spark context, SQL context, streaming context, and Hive context. All 3 operations that we generally use in Spark is binded to Spark session. But you can also use Spark context. So you'll see how to initialize and work with this. And coming to the batch mode, so when we leave our interactive mode, so come to the batch mode. So we'll write our transformation and actions in Python script, and we'll assign that program to Spark. But how to do that, right? So Spark support multiple ways to do that. One is local mode. Local mode, let's say you have 2 host. In one you are running your driver and executor. In another host you are running your executor, right? Or slave nodes you are running. So now if you want to run it in a local mode, what will happen? The Spark it says its own cluster management system, and in the local mode it will not execute your program in the cluster way. It will only execute your program in that machine that you have initiated. So this is basically used for development and testing purpose. So you do some kind of coding before giving it to any staging environment or production. You want to test whether your script is working fine in a low scale resources. So you can use local mode. Another is standalone cluster mode. So in the standalone cluster mode, there are 2 kind of deployment mode it supports. One is client, and another is cluster. Client means out of your host, from which node you are trying to run these Spark processes From that host, it will create one driver program. Okay, and if you mention cluster mode, then your Spark cluster driver will take the role as a driver, and it will execute your stage and tasks in the configured executors. For Python, the deployment mode should be always client because it does not support cluster yet for standalone cluster mode. But for other languages like Scala or Java, it support both. So here I'm in Spark for resource assignment, CPU, memory. So Spark own internal cluster manager will work as a resource manager. And we know, we have set it up Yarn also while setting up our Hdfs. So Yarn also can be used as a cluster manager, and we can assign our Spark jobs to Yarn so that the resource management part can be dealt by the Yarn. Okay, and for example, you have a cluster of 10 nodes in Hdfs, and you are running 9 data nodes and 1 name nodes, and you configure Spark for the same manner, like master and slaves in all 10 nodes, right? But you don't want to, whenever you assign the job to Yarn, so you don't want to run or involve all the data nodes as part of your executors, right? So in that case, there is one configuration named spark.yarn.executor.node level configuration, through which we can identify or we can configure that what are the Yarn nodes that we would like to see during the Spark execution. That is also possible. We can use subset of our nodes to be used while we are running jobs on top of Yarn. And nowadays is also support Apache Mesos and Kubernetes cluster managers. So we can sign job also Apache Mesos and Kubernetes cluster. So it can also run your Spark job in batch mode. So we'll see. We shall go now to the practical session, so that whatever we have discussed, and so we'll see how we can access Hdfs and run some operation in batch modes in Spark. So coming back to the first options, right? So now I am in my Windows machines, and that's why this is the PyCharm. So in the very first step, if we need to access our Hdfs, so I can see my Hdfs is running or not. Okay, there's some problem. Let me log in again. So yes, Hdfs is running, and I can see this Spark worker, master, Yarn node managers, resource manager, job history server, everything is running. This is second machine. So this is the primary node. I mean the name node. This is the secondary one. We can see in the secondary node, I mean our Spark worker is not running yet. So to access the Hdfs, the way we are accessing from here. So if we need to access programmatically, Hdfs, Hdfs. So if you want to see what are the, so this we can do in using the command line utility, right? So if this operation you'd like to run programmatically, how to do that? So first we need to install the Hdfs. So to do that, I can go to View, Tool Window, and go to Terminal. So I can Hdfs. So I should be able to install Hdfs. So it's already installed in my Windows machine where I installed PyCharm and Python. So that's why I said I mean the requirements already satisfied. Okay. And after that, in my user and home directory as the user $G, I have created one configuration file .hdfscli.tfg. There I have defined, I mean, I named this bdren hdfs, the alias name, and I have given the name node IP and 5070. This is the port, and the user configured is Hadoop. So that's the configuration we have to do it. So now go back to our Python script, and we have imported config packages here. So using config, we take an entry point of client. So get client bdren hdfs, that is already defined here, right? So this name you have to put it here. So you will get an entry point to the Hdfs. Now, if you want to run your operation, let's say on mydir or slash whatever, so you can do that. Right? And even after getting the files, you should be able to iterate using a for loop. So I mean, we can run it. It's taking some time. Sometimes it's might be due to the firewall policy. I haven't put the right rule here. So it's giving some exception that it cannot connect. Yeah. So now it is connected. The reason is initially, I mean, ports of HDFSs, I mean, that is not allowed in my firewall. And I haven't disabled the firewall. That's why these ports are not externally accessible. So I just flash the IP tables, and the ports are being, I mean, connected from my local machine, right? So from my local machine, I can connect to external HDFS using the port and IP mentioned. And if I now go to the HDFS, So I can see the similar. So we have around 5 items here. So it retrieves all the 5 files from the Hdfs. Okay. So, but if you want to do some kind of operation, like you want to download some file from Hdfs, or you want to upload files from to the Hdfs, then you would need certain amount of permissions to do that. Let's see, from an external file system, external OS, how can we achieve that? Okay. So now, we use the insecure client package, which has been imported already, and we have given. So this is another method, right? So that's why we are giving the IP and port number of Hdfs, and the Hdfs we know is configured with the Hadoop user, and we'd like to download the. In my here we have OneTrips.csv, right? We want to download it in G drive, and we want to upload OneTrips.csv that is already in my software binaries, and we will upload in the root directory of Hdfs. Okay. So let's see how it goes. So the primary operation has been done, but the other operations which we are requesting to download or to upload, this will not happen because of the permissions issues, right? So we are trying to access one secure systems from externally, so at least we need to have some authorizations to do that. So that's why though we can just see what file system we have, but we cannot do the upload and the downloads activities yet. So we'll see how we can, if we run this program in our Linux node, then how we can achieve that these functionalities. Okay. The last one is sometimes we require to run some command in OS, and from the output of the command, if you need to parse and decide some logical operations based on output, so you can use sub process. This is one package, and check output, and you can run OS command. And then when you grab that command output, then you can print it, or you can do some kind of operations that you would like to do. So for the time being, I'm just disabling this because it actually prompts some errors. So I'm running IP config, right? So if in my OS, this is Windows, if I run IP config, I can see the IP configuration details. So my IP is around, I have received some IPs from, is around 104. And this is the IP that I connected with my Wi-Fi router. So the subprocess command is executed, and all the outputs is grabbed, into this variable, and it is printed. Okay. So this is the way, whatever, if you are in the Linux and you want to run a command like this, let's say you want to run the Hadoop fs minus ls, and you want to see what is the file or directories that is on the Hadoop root file system, so you can do that. And you can also run put or get whatever commands using the OS command, or if you want to grab the output, you can use subprocess, right? The subprocess will give you the additional advantage of running the command, getting the output both, okay, so that you can work later on the output that has been returned by the OS. And this is, I mean, just so if we are sitting on one local file system, can be Windows or Linux. So, and we'd like to go through the directories, subdirectories, or file within that directory that we need to traverse. So this is the way, I mean, you can, so here we try to go through these software binaries in my laptop, Windows laptop. I would like to find out only the CSV files in this directory. So how to do that? This is the way, I mean, we can traverse to local file system. So in the software binaries D drive in my laptop, if I go into that, so we'll see, I mean, you can copy the path from here. So here I have trips, CSP, users, and weblog. So these are the CSV files in my directory. So it has been picked up by the code, because I say the file name ends with CSV, please keep those file name only. If I remove this, it will show all the files under this directory, okay? So this is the one, I mean, from the sitting on in Windows or external OS, how we are interacting with Hdfs. Now, if we are interacting within our Hadoop cluster nodes, so I have to configure the Hdfs CLI, and I have to give if I use the client package, we need to define in which directory we need to go through. So this can be even variable. You can set just like a variable, or getting a parameter in Python script, you can set it up. So this one is just counting your file numbers, printing that, and here, I mean, we are trying to download using the Hadoop user. We will be running this script, so then we should be able to download and upload. Okay. So for both upload and download, just notice that, I mean, this first primary path is for Hdfs, and the second part is for your local file system. Upload also is the same. So if you want to overwrite, then you can put a parameter, say true. So if any operation you'd like to overwrite. And in case of OS command, I mean, this is one way we are utilizing the package to interact with Hdfs. But if you want to run commands, right, a Hadoop fs or put get, this kind of command, so you can use OS command or subprocess like we discussed in the Linux OS. And in the similar manner, the way we traverse our Windows, there is no change for Linux, so it's the same way we can do that. So now let's go to, I mean, I have already uploaded the Python script. So this is the one, I mean, we are looking into PyCharm. So, I mean, just for checkup.
we have already configured. We'll see in the home Hdfs directory, because that is our user directory. And we want to see my dear also here, and we're counting number of files and printing the files. Then we are configuring the in-CPU client objects using our IP and port that needs to be given for Hdfs. And we are trying to download scripts.csv temp, and we're going to upload to Hadoop root one of the scripts.csv and do some command line operations as well using os.command. And we'd like to see we'd like to see the listing of files in MyDR and showing the output. And we need to traverse to our home Hadoop development and see what are the CSV files. That's the script. We want to run it. So it's saying in the MyDR, these are the five files that and so there are two operations being asked. One is upload, another is download, right? So if we see the download actions, it should provide the output into the temp directory. So this is my local Linux file system. So here, if you see the trip.csv, and the modified time is 2nd May 12:30, right? So if we can see the 2nd May 12:30, so it has been override. So it is downloaded from the Hdfs to here. Okay. So this is the download operation. And if we need to upload, let's say we have a trip.csv, and if we need to upload to the Hdfs root, right? So we can also verify the root. We should get one trip.csv. Okay, and this is also updated. If you see the update time, it's 2nd May 12:30 local time, Bangladesh. Okay, so it is already updated because there was one reference, and that's why it's updated. So this is the way we can interact. And also, if we come to the second operation, these are the files, and we'd like to see what are the CSV files under the home and development directory. So if we go to the local file system output, so we are seeing there are trips, weblog, and there is more one CSV file that is started like this part. So if we are here, and if we need to see what the files, so these are the files. Okay. So here, there are some folders, which is showing here. These are folders, so we are not interested to see. So if I like this, so we can see there are only trips, users, and weblogs, and another file is this CSV file. Okay. And others are basically the directory. So into the directory there is no CSV file. So it will start traversing the development folder, and it will go into all the folders, and it will start if there is any CSV file underneath folder as well. So it will take for you and make sure that all the CSV files are in your output, and you should be able to handle that. If you want to run some operation on a specific type of files in a directory or under this subdirectory, you can do that. And so we have already, I mean, run couple of commands. So that's output also we can see. So this is 2. I should be 1. So we have already run some command like what is the root file system details and what is under my Hdf. So that is using the command line utility. So that output also we can verify once. So I put Python and so this is the output. I mean, from the root, it's getting out. Okay, this is the output. So it has been ran using using the OS command output. Okay. So we can change our program a bit and see. I mean, how we can put let's say this directed file into the root directory of Hdfs. So let us, I mean, just change it. Can edit here. So corrected. We want to see the corrected file that is locally available. Okay. Into the root directory, right? So if we verify it, with the present condition in the root file system of Hdfs, so there is no. So you want to put one file into the root using OS command. Okay. So now our corrected one, it's already placed here in the Hdfs root directory, right? So I mean, so you can either use the package or use OS command utility to put your desired file in the Hdfs, or you can download it, or you can remove it. You can do any other things. So I hope, I mean, if you do this exercise, how to traverse your local OS is a Windows or Linux file system, or you can also traverse the Hdfs. You can perform different type of actions, accessing, deleting, or creating files even. That is also possible. So these are the ways, I mean, we should be able to perform Hdfs traversals and different operations. So now, I mean, if we move back to our slide just to see, I mean, so we have completed this section. And for Python 1, I mean, you would share some. So if you are having the similar problem like me, I would share, I mean, how to make Python 3.c compatible with Spark so that we can use both the external package and Spark running on Python 3.6. Okay. So I mean, let's do some operations on Hdfs, transformation and actions, some sample. And those sample operations that we'll do in interactive mode, we'll try to put into one Python script where we have to initialize Spark context or Spark session, because when we are running through PySpark, it is giving us SC as Spark context and Spark sessions
by default from the PySpark utilities. But whenever we are trying to run the Spark program in batch mode, there nobody will give us those, I mean, the entry point, right? We have to create those entry point in our Python script so that we'll see. And then we'll run these Spark scripts, I mean, in different ways, like local or yarn or standalone Spark cluster, and see how it behaves. So let us, I mean, do very minor, some basic operations. Then we'll convert it to. So we have one COVID-19 in the Hdfs, just so we have our earlier file, COVID-19, date-wise, country-wise, the death cases and total cases are there. So we can see I think in our, so this is the file. So I'm opening this one from my Windows, so don't get confused. And it's already uploaded in our Hdfs. So there is one date, and it has been separated day, month, year, number of case, deaths, country, codes, and some population details, something like that. Okay. So let us do some kind of basic operation and see how we can make one batch script. That's the main intention now. Okay. So for the time being, I mean, just start to a PySpark session. To import the SQL context, because here we use the Spark context yet. So if you this Spark session is available as Spark, and SC is available as Spark context. So we'll use the SC. Yet. So we'll get this SQL context. So we can initialize SQL context from Spark session as well. We'll see while we're creating batch. Okay. So if we need to load the COVID-19 data set, so let us load it into a data frame. So the name in our Hdfs is not trailing with .csv. That's why it's just /COVID-19, whatever the name we have given, you can just put it here. So we're trying to load the data into a data frame named df_covid. Let's get loaded. So let us see just the 10 top 5 data. Yeah, so the file is loaded, we'll load it. So if we want to do some kind of operations,
So if you want to run SQL command, we need to create that temporary view. Let's name it, COVID. And now if you need to, if you need to run some group by operations or using the SQL command. So we'd like to, bring the total number of cases, and as like SQL, we are renaming the columns country-wise from the temporary table that we have created from the data frame. COVID, name is COVID, group by country territories, right? And now if you want to do the same kind of operations. So now Spark starts executing that, because earlier it had, yeah. So we asked to do some actions. So now it's starting to do the previous transformation as well, and giving us the output, the total cases that we have renamed the column name into the SQLs, but we can rename the column names using the data frame API as well. We have already seen in the slide. And so per countries and territories, we can see lines separately. So it's just only 10. So there are a lot of countries into the. So if you need to filter, let's say, for example, for Bangladesh. So you can filter like this. So now we asked one operation at the end, right? So I put into this one. This is a dated file, so that's why it's showing total deaths and cases less number compared to present done. For example, up to this, right? For example, this. If we need to download the country-wise total case and total death into a new CSV file, not in interactive mode, we want to do in batch mode and following different methodologies which Spark supports, at least 2 or 3, so that we can understand, how to run the Spark job in batch mode in either local or Spark cluster or in ER mode. So I'm just moving out from here. So let's say this is the one, the data processing on Python.spark, spark.py. So this is my script that I have built for running our program. So this is my main function, and these are some techniques that I would like to highlight you to be used later on. For example, you want to take the input file as a parameter. So just remember that. So the command is like Spark submit, then you do some kind of parameter. Let us see the syntax first. That would be convenient. So let's say the Spark submit. Then we need to define who is the master. Here, when we are running on local mode, so the master should be the local, and in the bracket, whatever number we put, that number of CPUs will be utilized. And then this is the Python script. And then if you put n number of parameters, so from here that the number of parameters will be taken. So before that, whatever you are giving, that is not part of your argument of Python. So that's what I'm just trying to highlight here. So if you put COVID-19 here as a file, okay,
or path, then this argument you can access from your, I mean, array index 1, and the array index 0 will be your Python script name. Okay, so this is one, I mean, syntax whenever you are running, but in the command line you have to give the total this one. I mean, from here it will get, I mean, how to run it. So if you put local, then it will run on local mode. The device or host that you initiate, from there it will create the driver execution and it will run your process locally. So that's why, I mean, that this for the timing is visible. You can see also the arguments. So now I have not taken any arguments. And I have defined some loggers also in the Python, import logging, so that, I mean, you can also see, I mean, is a distributed computing program, so you can take logs details like this way, so that you can see if something goes wrong. I mean, you can see in which position. So logging in a standard way helps to debug you, and even if you give to the production, it's helps the user also to know, I mean, how it's executed. Okay. So now, first of all, we see, I mean, how we have, I mean, initialized our Spark session. So a Spark session has been, I mean, imported already from PySpark.cl session, import Spark session. So we have to initialize the Spark session. So I am taking one object SC, creating a Spark session to builder. I have given one name Spark data processing, and I am creating or getting one existing instance that we get or create. So this is, but in many of your production activity, you may need to setting up the Spark, this program, how many core it will use for driver or executor, or how much driver memory, how much executor memory, you can define like this. So that's why I have put this one, because now we are running in a very limited scale, right, in our virtual machine. That's why I'm not, I mean, initiating this one, but this is the way. Here, see, the maximum core will be 5, executor core, per executor it will be 2 core, and driver memory will be 8 GB, executor 4 GB, and then you can give your own name. Like this way, you can, I mean, setting up your Spark session object, which will be your entry point to do all the data frame loading, transformation, and action. So after this one, I mean, we have initialized our now we initially SQL context, because SQL context is required to load the data frame. So we are passing the SC, which is entry point of, I mean, an object of a Spark session, and we have initialized SQL context. So in the similar way, I mean, if we need to utilize Spark context rather than Spark session, so you can disable this line and you can use this one. So like this. So I have similar way. I have imported this Spark on PC on here. So Spark context is imported from PySpark. SQL context and Spark context is already there. So, and I have set it up our app name, and app name can be of a variable. So that's what I'm trying to show here. So if you have a app name defined before or part of your script, you can put it here. So it can be, even app name can be dynamic, and this app name you can find in your Spark GUI that we used to see and while job is running. Okay, so here we have defined parallelism, Spark core, like all application parameter you will find in our Spark class reference. I mean, how many configuration is supported. If you don't do any configuration explicitly here, what will be the default parameter, that is also listed over there. Okay, so you can check that. So this is another way. I mean, so when we configure this one, we can even configure our master with Spark master here. without during the Spark using the Spark session. So after installing the SQL context for a Spark session for our interactive job that we have already done, we need to convert it. So we have created one function. In the function, we are passing the COVID-19, the absolute part of the Hdfs. So this is the base part, and file name is COVID-19, which we can take even as startup or argument also. Then you can pass the SQL context to your function. Then it will, the execution flow will turn into here. So we are entering into the function, just the login, and we are loading that Hdfs COVID-19 here, right? This is the file. This is the way we should load. I mean, we already have done it in our interactive shell. And we have taken our login and printing into console that the data set that we have loaded, right? Data frame. So that is how many rows in there. So it's just dfcovid.count. This is just putting some random interval between 10 to 100 seconds, so that I mean we can go into the Spark application portal using 4041 or 424024 and see how it is being done, right? So that's why I put intentionally some skip time so that we get some time to see how it is being done. And then after loading the CSV into a data frame, now I'm creating one temporary view, and then we are running the group by operation in SQL statement on top of that temporary view. So that's why if you see the from COVID, it's already defined as a temporary view. So this is a temporary view or table, whatever you can mention, and on top of that we are doing some operation. And then the output of the group by operation, we'd like to, I mean, put into our local host, local file system, home Hadoop development under COVID-19 analysis. Okay, and we don't want to see this output in different parts in different hosts or executors. That's why this is the quality statement we have given, through which at least out of the executors that we are running. So one of the executors will be having the overall output, I mean, consolidated. So that's what I mean we have come to know in our last Spark class, right? And so we are having just the intention is to know, I mean, how we need to construct our interactive words into a batchmap. That's what I'm just omitting the filter options, right? So you'll see a consolidated CSV in which all the country-wise, we'll see total depth cases into a CSV file consolidated, not in a different part in different executor. Okay, so this is the script that we are trying to run in different modes. So initially we'll run in local mode, and then we'll run in Spark standalone mode. And in standalone, there are two ways. One is client, one is cluster. So Spark in Python, standalone cluster mode does not support cluster. So anyway, we have to run as client, and then we'll run the same script on Yarn and see, I mean, how Yarn takes our apps and keeps all the details logging, right? So I have already moved my script in the primary host. So the script is already here. Data processing on Spark. Because I haven't installed the Spark in my Windows machine, so I cannot run it here. So there is no such package of the script here. So whatever we discussed, this is already here. The same script. We call from the main function. We call the data processing function and loading in df copies, trying to log, trying to have some sleep time so that we can go and see how it is being executed. Otherwise, as soon as the application terminates, right, we cannot access the web. So now let us run as a local mode. It will run functionality stores, so it will not be executed in the cluster. Okay. So the driver and executor will work in the same host. So, and as we have very limited vCPU assigned for my virtual host. So I have only 2 CPU. So I would like to run this script only for my 1 CPU, right? So that's why I define local 1. In your actual implementation, you can make even 8 with that number of CPU, right? Otherwise, if you mention more CPU, it will wait for resources. So the Spark Summit is running our program. So now, if we want to see while it's running, 192. So our 6, right? So our job is running. So this is the master or the host in which we have provided the job. Okay. So we can see so these are chances. So you can see details from here also. So there are 6 stages. And if you click one stage, it will show you the tasks here. If you see the executor ID itself is a driver, it's working as an executor because it's a local mode, and it is showing the address, time, task, time details. These are the environments details. If you see, that is sitting as executor here because we have run as a local mode. They're processing around 11,000 or 10,000 rows, if I'm not wrong, and we are trying to process limited resources. So if you see the timing, right? So it's not OT. So if you are not using a Spark for large amount of data in a standard resource, you won't get the right amount of efficiencies. If we go to the Spark management GUI, so here also you can see we cannot see ours. So our data processing app is not assigned to the cluster, and that's why it's not recorded here. If you see. I just terminated it just to check. I mean, so we have asked to put our output into the COVID analysis.csv, right? We can see this is the detailed file that is generated, and if we see the time, I mean when it is written, May 2nd, 12:44. So it has been updated. As I was, accessing the web GUI, that's why maybe the process is hanged. So this is the local mode that we have, run, right? So in the local mode, we are defining the master. We will use local node, and it will initiate one driver program. Within the driver program, it will initiate. It will work as an executor also in a local mode. So it's generally used for development purpose. Now, and if you notice that is not even recorded by your cluster. So this is your Spark cluster. You should be able to see the names, but we have given a name. Our program name is the Spark data processing, right? So that is not even shown here because we haven't used the cluster yet. So if we need to use the cluster, Spark cluster, own cluster, and we need to run in a standalone mode. So let us run in a standalone mode. So we are defining now the master is the Spark. This is our host where the actual cluster driver is configured, and it has been accessed through 7077. I'm giving Spark Summit to run our program, the same program on Spark cluster standalone mode. So now it shall, contract. If you see you can see from the log also, it will contract to the Spark master here, connecting to master. So earlier it won't connect to the master. If you see the Spark GUI, you see this is our app, right? It's running. If you kill here, it will be killed, okay? So name is already here, and it's under running application. If you go in Spark data processing, so you can directly come to the UI that we'd like to see, right? So it's already running. It's part of the execution flow. You see the initial job has not accepted any resources. Check your cluster UI to ensure that workers have sufficient resources. Okay. So now I'm going to terminate it, and let's say if I want to see. So this is our master, and worker is also running here because we have configured like that. Yes, our worker, one of the worker is not running here. So let us try to run. Stop it. Let us stop it. all. Because now it's looking, I mean, all the resources. Basically, at least one CPU will be required. So it's not getting all the CPU because it never start showing up in this second. So now the worker is running right in the second house. So hopefully now we can run and it should not show any resource on the screen. We can again go to the Spark UI. $699. So I refreshed the page. So our new data Spark data processing is running, and we have two worker node live. Initial job is not accepted any resources. UI, okay. Two code is used. It will wait for some time to, but the message is saying that it's not getting the resources properly. So it's now running. Just check, I mean, who is using the resources. So we have killed some of the jobs. Maybe those are not, I mean, yet fully closed. Just to quickly troubleshoot the issues, I'm just starting it again. Yeah, so we should not have any other jobs running and which will be consuming resources. So this is, I mean, standalone. Then finally, I mean, we'll see the last one, the yarn method. We'll see. You should not get, I mean, start or so we have two running. We have two executors running here. And they are having two CPUs assigned and 1 GB memory assigned. We might have some memory constraint also. So we need to see because the memory is assigned. Just let me check. 1 GB. It might have some memory constraint maybe. So if it is cannot, I mean, get the right amount of CPU and memory, so there will be this kind of message coming. So still it should be able to run with the limited amount of resources. But I mean, for the time being, so we are closing the. So this will also run your job in master, Spark master, and it will also create the CSBs that is being asked into the Hadoop home directory, this directory. So if so by default it will get the required number of cores, CPU cores, as well as the memory. The default is 1 GB. So as I have configured 1 GB for my both VM, maybe due to some issues, I mean it's being blocked due to resource capacity. So we need to check the detail log. But this is one, I mean, how we should run the Spark processes from standard cluster. Now, if we need to run through the now let's see whether we are having the same error. So now we are assigning yarn to manage the CPU memory resource details. So there is one configuration I am used at Spark yarn submit wait app completion. So I say it false. Start running if there is any parallel jobs also. And we have defined master yarn. So it will communicate with our yarn which already been started. So your Hadoop conf environment directory that should be initialized properly in your Hadoop user bash RC so that it can create So this is our Ian cluster manager. We have configured Ian in the name node. So this is our job. It's still running. So Ian is now, assigning resources to drive an executor. So it has been already loaded the CSVs. Now it's the timer that we have put. Randomly it gets 28 seconds. So then it will move to still it's running. It is running our SQL statement. Because we have run group by operation, that's why yeah, so it's completed, right? So now if we go here, so Ian managed our job better than Spark on cluster manager, right? So it can manage resources better, so it's already finished. So now if we go to the history, 192.168.0.106. We have named it as Spark data processing. You can name your applications, and the application type is a Spark application, and it's succeeded and it's ran for 2 minutes. So you can see the history and what logs are there. We can also see here. So the BDN, this host name is not in my Windows host. That's why every time I have to put this, otherwise it will come. So there are errors and outputs. So you can go here. So you can find some minor warning alarms are also here. Okay. So this is the way so as part of Hdfs Hadoop, we know that there are two components. One is Hdfs and another is the MapReduce, right? So on top of MapReduce, because of its flexibility, accepting not only MapReduce job, it can accept other jobs like Spark jobs, and it can act as a manager. Okay. So now if we see, whether the yarn job provided the analysis result timely or not. So it's updated around 13.00, right? So now our time is 7. So it's been updated just part of our yarn job. So this is the file that we have asked to, give us an output country-wise, the total cases and dead cases. So this is the way, I mean, we need to, now if we go back to the slide, the specific slide, okay. So we have seen some activity or transformation action using PySpark, and PySpark will give you the Spark contest and Spark session entry using an object variable already, which you just need to utilize. But whenever you're running in Spark job using Spark Submit program in batch mode, you can either use local mode, Spark standalone cluster, or Yarn, or Apache Mesos, or Kubernetes cluster, right? These are the supported entities nowadays. For local, we see that the local mode can be initiated either from your executors, I mean master. Even you can execute from where you just configure your worker in the host. So in that worker machine, what will happen? There will be one driver which will be acting as executor also, and it will not create a cluster to execute your Spark job. So it will run your Spark jobs into a single machine, and in the single machine it will logically create driver and executor. Basically your driver will act as an executor. Okay, that's the local mode generally used for development and testing. And in the cluster mode, what we see, we are having some resource constraint, maybe some memory CPUs, whatever by default is required, is not getting that. So we need to see and tune that. But Yarn, we could see that it's can manage our program in a better way, and we have seen our output using Yarn. In the Yarn, we should be able to see if there is an error or output or details when it started and who provided the job, what type of application, right? So this is the way, I mean, we need to now if we need to run this job, I mean, in a schedule, right? So what we need to do that we just need to put this statement, right, into a shell script that we come to know in the last class, and you can put the shell script into your cron schedule, and periodically it can run, right, based on your business demand. So that is what, I mean, we are trying to cover in this class. So I mean, we can move to the question answer. I mean, if you have any questions. Hello, Ibrahim. I think so. We are done with our class today. I mean, if there is any question, then we can take it up.
Now, question. Hello, Polas sir.
Hi, Ibrahim. Yeah.
Okay, we can start the question and answer session.
Yeah.
Okay.
So, Ibrahim, I mean, do you want to give the audience or participant to ask the question, or I shall go to the question because I received around 8 questions.
Okay, firstly, we give advantage to participants. They press the hand raise button, enable their microphone.
Yeah.
Mr. Abhimanyu Pandey and Mithun Kumar Ghosh. Mr. Mithun Kumar Ghosh, can you hearing us?
Yes, sir.
Okay.
Yes, sir.
Yes, ask your questions.
So I have already written my is I have question related to the assignments. I need some more clarifications about assignments. Actually, in the first assignment, I've seen that there are Python and Python dot are treated as two different words.
Right, right.
So, should we go for that? That means any syntactical marks, should we omit that, or should we count that as different words, like my or first bracket my, then my underscore are different words or
So
same words?
Python, I mean, to answer your question specifically, that Python and Python dots are different words.
Yeah.
Yeah.
Okay. Sure.
So
And sir,
similarly,
one other
yeah,
thing.
similarly, my underscore would be counted as different words.
Different words. Okay, sir. Okay. And what about the new line character that is /n?
New line character, I mean, it's depends. I mean, how you program. So depending on your program, if we see, I mean, so that if you, I would like, I mean, you to omit that one. I mean, don't consider as a word. If you
Okay, sir.
consider, I mean,
I
yeah,
got it.
no issues. So, but it's not a word,
Yeah.
right? It's a new line entry, basically.
Yeah. I got it. And the other thing is, sir, is there any GitHub or GitLab repository that we can access and get your project's code?
Which I have already shown in last class. That
Yes,
is
sir.
part of, yeah,
Last
that is
class
already,
and today's
yeah, that is
class.
already part of the, I mean, documentations.
Yeah, I have got it via the PDF, but I wanted to know if there is any repository you can provide us via GitHub, because that way it would be more convenient for us to get access to your codes and the whole project. That would be more convenient
So,
for us.
yeah, understand, but I haven't planned for that. So, for time being, I mean, you can refer the attachment in the.
Okay, sir. Okay, sure. Thank you, sir.
Thank you.
Okay, Mr. Abhimanyu. Mr. Ubaidullah. Okay, sir, we can go the question. I hope no any questions from participants.
So it's mostly related to the assignment and the codes that I have done in last class. So that is already been shared in the PDF. Okay. Okay, please show the port allocation in Hdfs machine. Okay, so the port, I mean, we have configured, if you remember, Asad, the question that, Mr. Asad. So, I mean, if we remember the Hdfs configuration, so there are multiple files we have configured there. I mean, we did configure some ports for Hdfs. I think you can go to that, I mean, specific class, maybe third class. There are multiple files where we configure the Hdfs ports details. Is it acceptable to use file input and container in our past assignment? File input, yes, file input is requested for, I think, both of the assignments. Container one, I haven't got it. It's better to provide us just the codes. So we'll be running maybe in a Linux machine or Windows machine to check the answers. Assignment, sample file for assignment. Sample file for assignment is already been emailed to all of you. As I know, Ibrahim is right? I mean, the sample input for testing the codes of the assignments, that is already been shared, right?
Yes, shared. Already
Okay.
shared. The two PDF files. Am I right?
No, basically, I have shared the assignments in a doc file, and into the
Yes.
doc file there are attachments in the input attachments. If you send those input attachments separately, that's fine.
Yes. Yes.
Okay, fine. Can I remove the punctuation marks from the line? Question regarding assignment 1, remove the punctuation mark. Is there any punctuation mark already there? If because the input file would be variable, right? So we'll be using even maybe different input files to test your code. So if you are asking about some specific question, I cannot answer. I mean, we'll check your codes, standard codes. How should we submit the assignment? So that will be communicated, I mean, by Mr. Ibrahim later. For directory access, can I import globe? Yes, I'm not sure about globe, but if globe is a Python package and give you flexibility to accessing your directory, that's fine. Yeah, absolutely fine. We did not receive the doc file. Yes, you have shared. We shared, I think, the PDF files,
Sir,
but
I converted the doc file into PDF and upload website also shared by email.
yeah, but in the
Ibrahim,
PDF, yeah.
Ibrahim, please share the doc file. Okay.
Okay, I shared the doc format later.
Okay,
Because
immediately.
it's because it is creating many confusions.
Okay, it's okay.
So in the doc file, the input files are attached to the object. Yeah, so they can, I mean, easily download and test it. Yeah. So RDD, I mean, you are trying to. So RDD will go through one more time in the next class. So RDD is a resilient distributed dataset. It's a basic structure block of Spark. So whenever you load any data in RDD, that is a distributed dataset across your cluster, and you can do multiple operations on top of the RDD. So we'll see more even in next class also, and try to compare the traditional method of executing and executing on Spark. What's this advantage? We try to, I mean, simulate something. We only received the hands-on shell script doc. Okay. We need the testing file that will be shared. The doc file will be shared. So in the doc file, I have already provided the inputs details. Is there any assignment for Hadoop and Spark? Yeah, there will be one more assignment, and we will share the assignment in the next class, because the next class will be our last class. After that, we will provide one assignment which you need to do on top of Hadoop and Spark. Sample input, yeah, sample input part will be dissolved. So you want to use bash bin assays for assignment, you can do that, no issues. As long as the output is here, we are happy. But I mean, if in the assignment, if you request to use bin bash, I don't know why you are asking for that. I mean, if you have any challenge, bin bash instead of bin assays. So bin bash is more convenient than assays. I am not sure why you would like to use, but you can. I mean, we can test, no problem. So Ibrahim, I mean, we have went through all the questions. So most of the questions related to the assignment input file. Okay. So yes. I think, yeah, I mean, participants gets confused because in the PDF they cannot download the attachment, right? Yeah, that's the challenge.
Okay, I will share the doc format also very soon.
Yeah. So if there is no more question, I mean, we can close our session today.
Palash,
Yeah.
today, as we have some time, I would request you, if you go through the assignments. Then participant will be helpful how to do their assignments.
Okay. Let me open the assignment doc file that I have shared with Ibrahim. Yeah. So this is the assignment 1, right? So the testing procedure will be, we'll be using your Python code, and we'll be providing dynamic number of files. So your code should be able to take all these files, from the argument, and we need to give the output in a consolidated manner, like the word count, right? This is the output. Yeah. So here, just to show you, the sample already has been given. Maybe due to the PDF form, you could not able to download. Yeah. So that will be shared today. And so we are asking to use Python 3.x. Do not use Python 2. Files can be, the files that we'll be giving can be in your current, our running directory where you put the Python code, or can be in any directory in the local file system. And you need to show the running time of the program, how much time it takes to run your program. You cannot use external library to satisfy the requirement except the basic Python libraries. That means you cannot install anything like we installed today Hdfs. So you cannot use any packages except the basic Python libraries. And the last one, so you will be given with the data set like okay. It's giving some security warning. Let me check whether I have the copy, local copy in my laptop. To keep you safe. Okay, so the file format is very similar. Like, let me show you. Like this. So in the Linux machine, if you see the etc password, it will be listing your all the username, and their shells is here. So details and some other information, user ID or group ID is here. So you need to, so in our testing password file, which you need to take as part of your shell script as an argument. So from there, you need to identify the users which are duplicates in the file, first of all, and then the shells being assigned to the users in a unique form. If they are using 3 types of shell or 1 type of shell, you just need to print out the shells which are unique, not all the shells of the users. Okay. So first you need to identify the duplicate user in the password file. So if I go back to the sample, so from here there is a root bin. So if you Hadoop in the last section of the file, if I'm seeing the root or Hadoop one more time, so then we will need to collect the root and Hadoop, and we are seeing the Hadoop shell is bean bash, root shell is bean bash. So the unique shell would be bean bash only. The output will be bean bash because they are using the common shell. So you need to find out the shells and print out the unique shells, not all the shells of the duplicate users. So, that's all about the assignment. And how you need to print out, that is, I mean, given in this format, output shown like this. This is one, and the second section is like this. And the password file, yeah, it can be in different directory. So you can give execute permission to run your script. If you download our assignment directories, if there is no execute permission, no worries, we'll give it. If user is not giving the password file as an input, so your script shall show us that please run it correctly because you haven't provided the input file. Okay. So I think we have provided much clarification about the assignment. And don't think about Hadoop or Spark because it's not related to this. But this assignment work will help you to complete the final assignment, which will be utilizing the Python shell script as well as Spark and Hadoop. Yeah, Jahid, so that is, I mean, all from the assignment side. Yeah.
Okay, thank you, Balash.
Yeah. So I think we can close the session, right? So thank you, everyone. Stay safe, stay home. So see you in the next class.
Okay, sir. Thank you so much, sir.
Yeah, thank you.
Okay, Ibrahim, in the meeting.
Okay.